Hi, and welcome back to CloudNets, where networks meet cloud. And today we're going to talk about AI, and specifically about AI networking. And we have our chatbot. Yeah, we have our very own artificial expert, Ran. Thank you for joining.
My pleasure.
So, Ran, AI is a big thing lately with all ChatGPT and Bard and everything, and it's growing. And we want to talk about the challenges behind the AI infrastructure because, you know, AI, ML training, it's a very compute intense task, but also the networking, the backend networking that connects between all the parallel computers is a very, very important and critical infrastructure for AI. So what are the three, let's say, main challenges in AI networking that you know companies like the hyperscalers that are going into this market now needs to resolve?
Okay. I'll break it down to
three
things. First off, in AI, HPC as well, application is king. And it boils down to three main ideas or three main pillars. First off is that you have a variety, flexibility of different applications running on that same network. An AI network or an AI cluster needs to be more connected to the outside world versus an HPC, which is kind of more of a back-end kind of deployment.
Okay, so classic HPC is isolated, while AI is something that has the back-end and the compute and you know the training, but also the connectivity to the online realm.
And more varied. More different applications running at the same time, different sizes, different length, different duration of the application. That's more varied in AI, whereas HPC is more.
So basically, the network needs to be some kind of connected or online. So preferably, the backend and the front end are the same technology, but also very flexible, scaling up and down, and you know, accommodating various applications.
Yes.
Okay.
Correct.
So this is one.
That's number one. Item number two is that an AI network is big. HPC network is also big, right? It's not a differentiator, but AI is so big that when you take an application and run it in a very small scale, you get certain level of performance. That's good. When you expand the scale, almost linearly, as the network grows, the application performance degrades.
So when you talk about application performance, you talk about job completion time.
Job completion time is kind of a overall kind of sums it up in job completion time.
And in the networking domain, we're talking about non-stop connectivity, predictable connectivity, you know, failover,
in a nutshell,
loss.
The network needs to be completely transparent to the application. Like I said, application is king. The network needs to stay out of the way.
Do not disturb.
Do not disturb the application. So this is basically number two. Item number three is that AI networks are big. They are deployed by the largest players in the industry. They need to be rock solid. It needs to be technology which is open, which allows multiple vendors to chime in. Nothing that locks you into a certain application with a certain technology, with a certain vendor. Anything which is not a lock-in, anything which is more field proven and proven by multiple players and for a long duration, this is what an AI network needs.
Okay, so wow, those are some challenges.
It's not easy.
Just to sum up, and we will have another episode, I think, in order to understand how we resolve those challenges, because it's a fairly big task.
It's a very big
task. But just to sum up the challenges, first of all, we're talking about flexibility and connection online, meaning that you need to accommodate multiple applications. You need them to be connected to the internet in order to be interactive, etc. This is one big challenge. The second challenge is performance and scale, and performance at scale. That means that it should be non-stop, predictable, zero packet loss, very low jitter, etc., etc. And it needs to keep this performance as the scale growth, which is the main pillar of this challenge. And lastly, it needs to be a safe bet. You don't take chances here. You don't rely on one vendor. You don't rely on non-field proven technology. You need things to work. And as you said, you need to forget about the networking part, because the compute is the king. The GPUs needs to feel they are connected and nothing interrupts their connectivity. The networks needs to be there and needs to be transparent. So This is the big challenges we
Very
have.
big challenge.
And
Very big investment.
yeah.
And as such, you need to reduce the risk.
Absolutely. So thank you very much, Ron, for this.
pleasure.
And thank you for watching. Stay tuned for our next episode in which we will talk about those challenges,
Solve
but
them.
from this resolution angle. So see you next time. Don't miss it. Bye-bye.